Hello everyone. Hope you're all doing well. I'm Stuti Kansal, a volunteer at Applied Forensic Research Sciences, and today I am going to give a presentation on the topic forensic physics. So, in this presentation, we are going to take a look at what basically forensic physics stands for, what branches does forensic physics involves, then what are the evidences whose examination come under this field, along with its current scope with some famous case studies regarding forensic physics, and at last, we're going to conclude our presentation with the significance of studying this field and the summary. Since we have a lot to study, we are going to divide our presentation into two parts. In this part, we're going to study up to the evidences in forensic physics and we'll cover the later topics in the next part. So, let's begin. Our first title is Basic Concepts. So, what is forensic physics? It is nothing but a branch of forensic science that deals with the applications of all the principles and techniques used in physics to solve the legal cases in the court of law. Or we can simply say that the forensic physics is the application of physics in solving the civil or criminal cases. Thus, it generally comprises the analysis of physical evidences, including that of ballistics, like firearm, bullet, etc., and materialistic analysis, like glass evidence, paint flakes evidence, or soil found at the crime scene. The process of crime scene reconstruction also comes under this department. Traditionally, the forensic physics was only limited to the measurements of soil and glass examinations, including their density and refractive index measurements, but in recent times, the forensic physics does not only include the comparative studies of various impression marks and chassis marks, but also involves the techniques of restoration of erased numbers upon metallic objects, the examination of stamp impressions, and the analysis of paint and glass articles. These all come under various branches of forensic physics. So let's have a look at them. The first branch is of the material analysis, in which the forensic physicists identify and compare the materials found at the crime scene, including fibers, soil, and metal flakes, to link them to the suspects that eventually help in the crime scene reconstruction. The second branch that we have is the forensic biomechanics, in which the physicists reconstruct the mobile type of crime scenes, including vehicular accidents, by performing speed calculations and impact forces. They also investigate injuries produced during such cases. The next branch is the firearm examination or ballistics, where the ballistic experts obtain, examine, compare, and analyze the various unique markings present on the firearms, bullets, or casings to link them to the suspects. Interesting, isn't it? Moving further, we have fluid dynamics, in which the specialized blood spatter analyst investigates the blood spatter patterns to determine its direction and cause, eventually helping them to reconstruct the crime scene. This department also includes the investigation of vehicular accidents happened in the water bodies. Our fifth branch is the audio-video analysis, where the principles of optics and sound waves are implied to check the tampering of audios and videos. It also involves the analysis of gunshots and other acoustic evidences by examining the sound wave patterns and frequencies. The last branch of forensic physics includes the forensic optics, which focuses on the principles of optics, like the phenomena of reflection, refraction, and polarization, to investigate the crimes involving various materialistic evidences. Moving on to our next topic, we now have the common types of evidences that are examined under the Department of Forensic Physics. The first being the glass evidence. The name itself suggests that the glass evidence includes any type of glass piece or an article present at the crime scene. We are going to study the collection, packaging, and preservation for all types of evidences. So, the procedure for collection of glass evidence starts from wearing gloves and protective eyewear to avoid any contamination or injuries. So, the first method is by picking the small fragments or glass pieces carefully by using forceps and tweezers. Usually, the forceps and tweezer method is used for all types of trace evidences to prevent their contamination. The next method is to use a vacuum with a clean filter, usually to collect very small or fine glass particles from cloth surfaces or mattresses. One more method for collecting the very big or prominent glass pieces or broken articles is to gently sweep them on a dustpan using clean and soft brushes. Now, for the packaging and preservation of the collected evidence, we must first ensure that all the packaging material is clean and sterilized. We should place each glass fragment separately in different containers, usually covered in cotton, to prevent cross contamination, breakage, or any moisture present during the transportation. The packages must be labeled and sealed properly to prevent any degradation and to maintain the chain of custody. Next physical evidence is the fiber evidence. It may include any type of cloth piece or fiber samples that are found at the crime scene. The collection method is somewhat similar to that of what we studied for glass evidences. Clean tweezers or forceps are used to pick up any individual fiber pieces, while vacuuming with a clean filter and a low suction is used to collect loose fibers from any type of smooth surfaces. One more method which can be used here is by placing adhesive tapes onto the fiber suspected surfaces to collect them effectively. For packaging and preservation of fiber evidence, similar rules are followed, like placing each fiber in separate and dry containers such as paper envelopes or plastic vials to prevent the cross contamination, and sealing and labeling the containers with general details like appearance of the fiber, its color and texture, along with the important details like case number, location where the evidence was found, etc. Moving on further, we have soil evidence, which includes the soil samples from primary and secondary crime scenes along with the nearby areas surrounding them. Now, to collect the soil evidence, we must first mark the area to be collected and then use a clean shovel to dig the soil and collect it from both the surface and the deep layers. The soil samples should be collected from different depths if it is relevant to the investigation. For the packaging and preservation, the same steps that we learned earlier are followed. We must use a separate and clean container for every soil sample, and also to prevent the cross contamination, we should seal them and store in a cool and dry environment to prevent any microbial growth in that. Fourth evidence is the paint evidence that generally includes any paint flakes or paint scrapings from the walls of the crime scene area. To collect these paint flakes, we have three different methods. The first one is using a clean and sharp tool like any knife or scalpel to carefully scrape off the paint samples from the surfaces, called as the scraping technique. Otherwise, we can also peel off the paint samples using clean tweezers or forceps. One more method to collect paint evidence, especially from delicate surfaces, is to take a clean acetone or alcohol moistened cotton swab and rub it on the suspected surface in a circular motion to collect the trace amounts of paint. For its packaging, we must again use clean and dry containers like plastic vials and store them in a dry and cool environment to prevent their degradation. One thing we must take care is that we should collect the paint evidence not only from the primary sources like walls, but also from the secondary sources like vehicles, clothing, or weapons. The last and the most important evidence is the tools evidence. That includes any kinds of tools, weapons, or tires, and the impressions made by them on the objects. Now, for the collection of these impressions, we can use different photographic techniques to create their 3D models, or we can create 3D casts of these impressions using POP or dental stones. One more technique to lift 2D impressions from the surfaces is by using an adhesive lifting tape or gels similar to that of collecting fingerprints. Their packaging and preservation is somewhat similar to the fiber evidence which we learned earlier. We should first record the labeling of characteristics of impressions, including their dimensions, patterns, or any other individual characteristics. And we should seal them in separate clean containers in dry and cool environment to preserve the evidence. And during the transportation, the package must be kept sealed between the cotton so that the cast does not break. With this, we come to an end of the part 1 of our forensic physics presentation. I hope these concepts are clear to you. Stay tuned for part 2. Thank you.